Hey guys, so today we're going to start off with a warm-up from your notes. So go ahead and please take out your notes, open to page 133 and 134, and please do these two problems. Go ahead and please pause the video so you can complete these problems, and then once you're done, press play again and you can see the solutions. So it looks like for number 15, it looks like they are congruent. And the observation here is it looks like there's a reflection and a translation. So the interesting thing here is because they didn't tell us which way to map it, they didn't tell us which was the pre-image and which was the image, right? There's no primes or anything. For that reason, we can actually decide how we want to do things. I would say I'm going to go from C, D, E, F. I guess there's a B there. So B, C, D, E, F to J, K, L, M, N. I'm choosing to make the bottom one my pre-image. And also, I think I'm doing that just because it's a little darker, but it doesn't really matter. So the observation is first there's a translation. So we're going to go from X, Y. Notice that we're shifting. We're going to have to move it so the D prime ends up being right here. And so everything is getting shifted over, looks like 2 units. So there's D prime, here's C prime, and so on. So to shift to the left, that means that X is going to have to get smaller by 2, and the Y is not going to change it. And now from there, we're going to observe that there's now a reflection. Now the stuff on the bottom gets flipped up to the top. And so we're reflecting over the x-axis, and the notation for that would be x comma negative y. So they are congruent, and the reason is because there are 2 transformations. One of them is a translation, and the other is a reflection. Okay. For the other one, we are told that they are congruent. Okay, right away we're told that. We just need to find a sequence of transformations that goes from, this time we are being told what order to go. We're going from the left shape to the right shape. And we want to give the coordinate notation for the sequence of transformations used. So once more, I'm going to observe that there is a translation and a reflection. I failed to mention on number 15, but the order doesn't matter. On the last one, I could have reflected first and then translated, and it wouldn't matter. Sometimes it'll affect what your answer is a little bit, but in this case, you can just switch the 2 and it still works. In this case, how about this time, let's do the reflection first. So I'm going to take this and reflect so that X prime ends up being over here. Z prime ends up being right here. W prime and Y prime. So this would be my first image. I messed something up. Oh, I know where I messed up. I connected them in the wrong order. Let's see, those 2 lines don't go there. The points are in the right place. I'm just going in the wrong order. I need to erase one more here. Erase both. Okay, so that's fine. And then that, and then that, and then that. Okay, so the first thing we're doing is we are reflecting. And this time we're reflecting over the y-axis, so the notation would be negative x comma y. And then we're going to translate. We're going to observe that we just have to shift this up 3 units. So the x's don't change any, but the y's go up by 3. Right? All the y's are getting bigger by 3 because we have to go up 3 units. Okay, so this is reviewing what we did last class. Now, we're going to continue talking about congruence. In fact, that's a pretty big part of a lot of what we're going to be doing in this class. And so today we're talking about corresponding parts of congruent corresponding parts of congruent figures are congruent. What I mean is this. Let's say we're given this congruence statement. So let's start with this. This right here is called a congruence statement. It's basically an equation that tells us what two things are congruent to each other. But the thing is, the order completely matters. Notice in the first shape, the A is the first letter. And in the second shape, the D is the first letter. That tells me that angle A is congruent to angle D. Because, again, A showed up first over here, D showed up first over here. Likewise, the middle letter, B, that angle is congruent to the other middle letter, so that would be angle E. And the last letter is congruent to the last letter. So the order definitely matters, because if wherever a letter appears in one shape, the letter that appears in the other shape is congruent to it. Likewise, sides. Okay, when we draw a triangle, we don't need to draw this, but if I draw a triangle ABC, there are basically 6 components to this, right? There are 3 angles, and there are 3 sides. So now let's talk about the sides. Let's start with segment AB. Segment AB is congruent to, well, I'm going to observe A and B are the first 2 letters. So over here, use the first 2 letters, I get segment DE. So again, because the letters show up in the same place of the congruence statement, that means that these 2 parts are congruent. Likewise, BC, because those are the last 2 letters, is congruent to EF, because those are the last 2 letters. And then finally, AC is congruent to DF. And basically, just to summarize this, on page 140, we have corresponding parts of congruent figures are congruent. It says that if 2 figures are congruent, then the parts that match up are equal to each other. Congruent means the same in every way, same size, same shape. And so we can say that the little pieces of one are the same as the little pieces of the other. So we can use that to answer some questions. Let's move on to example 1 here. And again, please note right off the bat, we are told that ABC is congruent to DEF. That tells us a ton, because that tells us what pieces correspond to what other pieces. So I'm going to observe, looking at the congruent statement, DE, those are the first 2 letters over here. So that's going to be equal to the first 2 letters over here, which would be AB. And DE is equal to AB, because DE shows up in the name of its shape in the same place that AB shows up in its. And then I'm going to look at the picture. Oh, look, AB is 2.6. So I guess that means that DE is also 2.6 centimeters. Right? Congruent means the same in every way, same size, same shape. Likewise, the measure of angle B is equal to, well, this is equal to the measure of angle E, because B was the middle letter of the first triangle, E is the middle letter of the second triangle. Looking at my picture, I'm going to notice, oh, look, angle E is 65 degrees. So that means that angle B will also be 65 degrees. Okay. If they are congruent, that means that all the parts that match up are congruent as well. All right. Consider example 3 here for a second. So the triangles shown the triangles shown in the figure are congruent. Can we conclude that JK is congruent to QR? Well, the answer here is no. And the reason is this. In the earlier example, in the last example, we said that DE was equal to AB, but that's only true because we were given that congruent statement. We were given the statement to tell us what matches up with what. On this example, we don't have a congruent statement. We don't know that JK goes to QR. Maybe JK goes to PR. I don't know. The point is, no, we don't know they're congruent because no congruence statement is given. Okay. I'd like you to try the problem at the bottom of the screen here. Try out this problem. Again, pause the video for a moment and come up with an answer for problems 4 and 5. So once again, looking at the congruent statement, if we want to find SU, well, here's S and here's U. Notice those are the outside letters. So that's equal to the other outside letters, V and X. So SU is equal to VX. And then looking at my picture, oh, VX, that's 43, so I guess that means that SU is also going to be 43 feet. And then on number 5, angle S is the first letter of that triangle. So angle V is the first letter of the other triangle. So S is equal to V. Now looking at my picture, angle V is 38 degrees, so angle S will also be 38 degrees. Notice I'm not looking at my picture at all. I'm not relying on, oh, well, let's see, what's in the upper right-hand corner, what's in the lower left-hand. I'm not looking at that at all. I'm looking 100% at the congruent statement because that's what tells me what matches up with what else. All right, let's take a look now at example A. So once again, we're told triangle ABC is congruent to triangle DEF. One word of caution. All of the examples we've seen so far, these letters have been alphabetical. They do not have to be. I could have been told that ABC was congruent to EFD. Okay, letters do not have to go in alphabetical order. And if I'd been told that instead, I'm going to scribble this out in a minute. But if I had been told triangle ABC was congruent to triangle EFD, that would change the problem completely. Because now angle A corresponds to angle E. Whereas over here, angle A corresponds to angle D, because those are the first two letters. So it's not all about alphabetical. It's about what order is given to you in the problem. But let me scribble that out because that is not what we're doing here. So AB, well, let's see. A and B are the first two letters. D and E are the first two letters over here, so I guess that's going to be a DE. So AB is the same as DE. Cool. Well, looking at my picture, looks like AB is 3x plus 8. DE is 5x. And we just figured out that those are equal. So I can write 3x plus 8 equals 5x. We can solve this, subtract the 3x over, and divide. We get x equals 4. Now we're not done yet, because the problem doesn't say find x. The problem says find AB. Well, we knew that AB was equal to 3x plus 8. Instead of x, I can put number 4. 12 plus 8 is 20. Right? This problem didn't say find x. It said find AB. So once we know x, we can plug it in to solve for the thing that we want. Let's look at example B here. Okay, now, I didn't print it here, but once again, we're told the triangle ABC is congruent to triangle DEF. The observation here is that angle D that we're talking about is in the same spot as angle A. So I can say that the measure of angle D is equal to the measure of angle A. Well, looking at my picture, angle D has a 6y plus 2. And angle A has a 5y plus 11. If I subtract the 6y over, we get, or subtract the 5y over, we get y equals, subtract the 2, we get 9. So y equals 9. And then angle D, again, problem didn't say find y. It said find the measure of angle D. So that would be 6y plus 2. But we can replace the y with the 9 that we just solved. 6 times 9 is 54, plus 2 is 56. Okay. Once again, please pause the video for a moment and try problems 6 and 7 on the same page. So once again, we're given this congruent statement. Don't worry about the word quadrilateral. It's basically, instead of a little picture of a triangle, we have the big word quadrilateral. But it doesn't matter. The important part is that LM, there are the first two letters over here, and that corresponds to these first two letters, which would be GH. So LM is equal to GH. In the picture, LM is 3x minus 13. do it again. 6x minus 13, excuse me. And GH is 4x plus 3. We subtract the 4x and add the 13 and divide, we get x equals 8. One more time, problem didn't say find x, so LM is, let's see, 6 times 8 minus 13. 48 minus 13 is 35. So LM is 35. And then angle H, I'm going to notice that angle H is in the same spot as angle M. So the measure of angle H equals the measure of angle M. Looking at my picture, H has this equation, 9y plus 17. Angle M has this equation, 11y minus 1. So let me move the 9y over, move the 1 over, and we get y equals 9. Finally, the measure of angle H was, let's see, it was 9y, so 9 times 9 plus 17. Let's see, 81 plus 17 is 98. Yeah. So my final answer for the measure of angle H is 98. All right. Well, that is the end of the lesson. Please go back to my website, go to the classwork, and start working on that. There's a couple of pages on there, and then don't forget to check your answers when you're finished with that. Thank you very much, and I'll see you when I come back next class.